Hello, today we will be reviewing special right triangles and right triangle trigonometry. There are two types of special right triangles. The first one is a 45-45-90 triangle, and the second one is a 30-60-90 triangle. The hypotenuse of the 45-45-90 triangle is x radical 2, and the two shorter sides are represented by x. In the 30-60-90 triangle, the hypotenuse is 2x, the side across from the 60-degree angle is x radical 3, and the side across from the 30-degree angle is x. The first practice problem we are going to complete is a 45-45-90 triangle. The two corners are 45-degree angles, and then you have a 90-degree angle in the bottom left. 8 represents x, and the hypotenuse is x radical 2. The object is to find x radical 2, and since you already know 8 is x, all you gotta do is replace x with 8, and your final answer is 8 radical 2 for the hypotenuse. On to the second practice problem, which is also a 45-45-90 triangle. Two corners are 45 degrees, and your bottom left is a right angle. It is given that the hypotenuse is 12, and you have to find x. Since you know the hypotenuse is x radical 2, and the hypotenuse is also 12, you set x radical 2 equal to 12. You divide over the radical 2. You then got to cancel the radicals in the denominator. Multiply radical 2 on the numerator and denominator. It becomes 12 radical 2 over 2. Simplify, it's 6 radical 2. That is your answer for x. Moving on to the third practice problem. This time we will be completing a 30-60-90 triangle practice problem. There's a right triangle on the bottom left, 30 degrees to the right, and 6 degrees at the top. 3 is given as the x value, and we are trying to solve for 2x and x radical 3. In order to solve this problem, all you have to do is replace x with 3, as 3 is given as the x value. So x radical 3 equals 3 radical 3. And 2x equals 6, because when you multiply 3 and 2 together, you get 6. So the answer is 3 radical 3 and 6. Moving on to the fourth practice problem, which is also a 30-60-90 triangle. Once again, 90 degrees in the bottom left, 30 to the right, and 60 up top. It is given that x radical 3 equals 6 radical 3. The hypotenuse is 12. You're trying to find x. You can do this two ways. You can either set 12 equal to 2x, or 6 radical 3 to x radical 3. In both cases, you will get the answer of x equals 6. Either way you do it, as demonstrated. And that is all. Moving on to right triangle trigonometry. To find a side, you use SOHCAHTOA. Sine is opposite hypotenuse, cosine is adjacent hypotenuse, and tangent is opposite adjacent. These are written as fractions, as you put opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent, as demonstrated in the video. In addition, to find an angle, you use its inverses. For example, if you're trying to find an angle and given is the opposite side of the hypotenuse, you do the inverse of sine, opposite hypotenuse. Same thing goes for cosine. If it gives the adjacent side of the hypotenuse, you do the inverse of cosine, adjacent hypotenuse, and same thing for tangent. If it gives you the opposite side and the adjacent side, you do the inverse of tangent, opposite adjacent, to find the angle. Now we will complete some practice problems. We are going to solve for x first and then find the other side. We're going to use sine theta equals opposite over hypotenuse, because x is opposite of the angle and the hypotenuse is given. The angle is 53, so our equation is sine 53 equals x over 8. Since we are solving for x, we multiply 8 over, so it's 8 sine 53 equals x. In order to solve this, you can just plug this in to your calculator and you get your answer. Now, in order to find the other side, we can use Pythagorean theorem, which is a squared plus b squared equals c squared. And we already have our a and c value, and all you have to do to find the b value is square the hypotenuse and subtract the a value squared from the c value squared to get b squared. And then after you get b squared, you take the square root of the number you get. And after you take the square root of b squared, that just leaves you with b. And that is all. Moving on, now we are going to complete a practice problem using cosine. We're going to find x and then find the other side. The angle given is 47, and x is adjacent to it because it's next to the angle. And the hypotenuse is given as well, which is 11. We set the problem up as cosine 47 equals x over 11. Since we're solving for x, you multiply 11 over, so it becomes 11 cosine 47 equals x. Plug it into your calculator and get the answer. In order to find the other side, you use Pythagorean theorem again. A squared plus b squared equals c squared. In order to find b squared, you must isolate it. So you subtract a squared from c squared, and c squared is just the hypotenuse squared. So you isolate b squared. And then after you get b squared, you take the square root of the number you get, which leaves you with b. And that is all for this problem. On to another practice problem. This time we are using tan as we're trying to find the opposite side of the angle, and we are given the adjacent side, and the angle value is 12. So you set this problem up as tangent of 12 equals x over 25, which is opposite over adjacent. We're solving for x, so you multiply 25 over, and it becomes 25 tan 12 equals x. You plug this in on your calculator and get the answer. Now you have to find the other side, which is the hypotenuse. You use Pythagorean theorem, which is a squared plus b squared equals c squared. You already have a and b, so you square a, square b, add them together, set them equal to c squared. After you add those two numbers together, you take the square root of it to find c. And that is all for this problem. Now we are doing some practice problems with inverses. This time the sides are given, we're trying to find the angle. So we are trying to find theta, and given is the opposite and the hypotenuse, so we're using sine, the inverse of sine, 3 over 7 equals theta. You can plug this in on your calculator. to get the answer. And in order to find the other angle, you add 90, and the angle you just solved for, set it equal to 180. Add the two angles you know together, and subtract it from 180 to find the missing angle. And that is all for this problem. Now we are solving another practice problem. We're also trying to find the value of theta. This time we're using the inverse of cosine because given is the adjacent side of the hypotenuse. So it becomes the inverse of cosine, 8 over 10 equals theta. Plug that into your calculator and you get the answer. And in order to find the missing angle, you add the two angles you already know together, and you set it equal to 180. You then subtract the two angles you already know from 180 to find the missing angle. And that is all for this problem. On to the last practice problem. This time we're using the inverse of tangent because given is the opposite and adjacent side. You set it up as tangent, the inverse of tangent, 3 over 6 equals theta. You plug that into your calculator. And in order to find the other side, you add the two numbers you already know together. You subtract them from 180 in order to find the missing angle. And that is all. Once again, thank you for watching. I hope you enjoyed. Please like, comment, and subscribe. And if you have any questions, please ask Mr. Mangieri, not me.